First, I will introduce myself. My name is Ghulam Mujtaba. I'm currently assistant professor at Regis University, Denver, Colorado. So for today's talk, I will present the research delivering personalized content on Edge AI. So the core question, central question arises like how we can create efficient, personalized multimedia experience on resource-constrained devices like smartphones and set-top box within next generation streaming platforms. So the objective of the research is that we want to generate or deliver the content which should match for the individual preferences, as every user have a different preferences. Meanwhile, we want to develop a lightweight framework that can use for generating the personalized multimedia content. Meanwhile, we need to design a kind of solution which is optimized for the client-side implementations. So we will discuss all those in the next coming slides, what is mean by the client-side implementation and the personalized multimedia generation as well. Meanwhile, additionally, we want to discuss like create a solution that can understand both user preferences and device constraint. Device constraint can be the power consumption as well, along with the other parameters in smartphone devices or other devices. Additionally, we want to establish a new approaches for the next generation streaming platforms for that prioritize the personalization and the user privacy. Uh, do you have any question? Okay. Okay. So as Michael Kapoor said, that getting information nowadays from the internet is almost similar like drinking from the hydronet. So the recent statistics in sir, I can hear you. आप जो भी उर्दू में बात कर रहे हैं, if possible, kindly mute it. जी. In 2025, there are around 85% global traffic or the video streaming videos, different videos. Right now, as we are, I'm giving talk on using some platform. Most probably, you are watching maybe my face. I'm not sure because I have opened the camera. Meanwhile, you are also seeing the content like these slides on the streaming as a part of the streaming content. So there are over 500 of videos are being uploaded every minute in 2025. So 500 of hours of videos. Meanwhile, average adult in USA is watching around 7 hours of video content daily. So, and the typical streaming platform generate around more than 100 billion in annual revenue. And typical streaming subscribers now spend around like a 45 minutes just browsing the content before selecting and curating, which is a kind of significant decision fatigue. So it requires like almost 45 minutes if you want to watch certain content on YouTube or maybe Netflix or other social media or other streaming platforms. Most probably you are spending 45 minutes just browsing, like checking, jumping on some specific content, maybe checking the specific needs like their thumbnails, animated GIFs, and so on and so forth, before actually trying to see the specific content. So there are different kind of choices we have. For example, if you want to read a news article, there are plenty of news, for example, based on our location, based on our language, based on other interest. Like some people may like sports, some may like politics, some may like the other forms. So based on the choices, we need to figure out which news we need to watch. Similarly, if we want to watch a video on streaming platforms, there are many videos are there. Sir, can you kindly mute it, please? I can hear you actually. Thank you. So if we want to watch a video, like there are several videos, so we are not sure which video we need to watch. So if we want to play games, there are plenty of choices and games available. It's more kind of a decision, again, fatigue in order to select and play that certain game. And if we want to listen certain music, there are several songs or audios on different platforms. So it's really hard to make a choice. So there are so many options now out there in a different platforms. So it's really difficult to make a certain decision on a short period of time. So in the traditional approaches, the most of them are the server driven approaches or server side approaches. For example, there is a new broadcast video on the let's say Amazon Prime or other Netflix, other platforms. So based on the content, since server driven have already the video content, and they collect the user data. So what they did, they generate the personalized content on the server driven solutions. Like they can generate the video summary, they can generate the thumbnail GIF, and they can generate the other personalized multimedia content. But there are certain limitations. For example, user privacy. Since they are collecting user data and we are not sure how much their data is collecting, so it's very challenging to identify the data they needed for the certain operations. So there comes the user privacy. Just for information, anything you are chatting with the chat GTP or other LLM based techniques, it can be used against you. So as in by law. So these all those server driven approaches, they are using the they are using they are collecting the user's data. Meanwhile, the optimal video length, for example, one user may like a 5-minute summary, other user may like a 10-minute summary. So based on the user's preferences, server-driven solution, they have to generate the content accordingly. And if there are overwhelming users, if we saw during COVID time, even Netflix has to reduce the resolution for the certain region because there were so many users during the COVID era. Other thing is it's really hard to collect the real-time user interaction. Right now, for example, I'm giving lecture, and some people are like reacting like they are laughing, maybe they are surprised, maybe giving some expression. So in order to collect those data in the real time, it's more challenging, and it comes with the again user privacy. So like the client device has to collect the data, and meanwhile the data will be transmitted to the servers site, and then it will be further processed, and then it requires extensive computational resources because video feature length videos or long form videos, videos which are more than 10 minutes, we call them long form videos, required computational extensive computational resources along with the storage and the bandwidth in order to process those videos, and challenging to handling the companion devices. For example, if you are watching the content on the smartphone, and if you switch to the laptop or other larger screen, how you're going to process those content. So right now the streaming platforms, what they are doing, they are generating the content, one size fits for all content. Like for example, if they are generating video thumbnails and animated, if you have observed on the YouTube, they are almost same. If let's say Muhammad is almost, if he's using YouTube on Pakistan, and I'm also using from USA YouTube, the same, I'm most probably seeing the same content, like on the recommendations. But meanwhile, every user have a different interest. For example, one user may like Mujtaba like the horse riding scene, and the Kim like the action scene. So based on the user interest from the same content, we have to generate the we have to pay attention, because these content is very useful for the CTR. CTR is the click-through rates. So the personalized content can like increase the CTR by 20 to 30%. So which can be really economically important for the different streaming platforms or different content provider, because they want more kind of engagement. So their user expectation for personalizing growing across all the platforms. There are industry shortcomings, like current solutions are primarily based on the server-driven solution. For example, Netflix and the YouTube, Amazon Prime, and Hulu, so on and so forth. And there are very limited personalization occur at the content selection. Like content selection is kind of recommendations. Recommendation and content generation are two different things, not the content personalization. So there are like a privacy concerns with the centralized users behavior tracking. So there the personalization have a three different dimensional challenge. One of them technical, like it required a processing real-time processing requirements. It has a bandwidth limitations. Meanwhile, they are existing with the we need to integrate with the existing platforms with a 1/10 of the server computation on the end user devices. Meanwhile, in their second challenge is the user oriented, like there are context and subject dependency. There are different contexts in the video. In videos, we need to process and understand, and there are varying personal preferences. As we discussed earlier, one user may like the action scene, other user may like the horse riding scene or romantic scenes. So, and their users' interests are keep changing with respect to time. It's really difficult to process those ones. And third challenge is the data. Like there are diverse inputs of farmers in the videos or in the general content. And there, as we discussed earlier, there are 500 odd minute of videos upload rate. And it's extremely challenging to like generate the personalized content from those long feature length videos, because the scale of the data is so massive, so big. So in the proposed approach, like we did use the thumbnail container on the streaming platforms, on like let's say on YouTube. Most probably you are hovering the mouse on the video bar. So these I'm calling them thumbnail, and the 5x5 grid I'm calling them thumbnail container. So I'm the kind of first researcher who used those thumbnail in order to analyze the feature length videos. So the key advantage was that instead of processing the entire full-time video, which is 2 GB, what we did, we used the thumbnail containers, which are almost 5 MB. And then we were able to process them on the user devices. For example, in most of my papers, I have used the Jetson devices, Jetson Nano and Jetson TX2 as well. So we can, by doing so, we were able to generate the different multimedia content. Like we were able to generate the movie trailers, we were able to generate the obtain the animated GIF, and along with the video summaries. And then based on the user's interest, for example, one user may like the romantic scenes, other may like the action scenes. Based on the user's preferences, we were able to generate from the same video content. So there were some, this is the like proposed system architecture. There were some client-side components. The orange boxes that you are seeing, like event detection module and personalized detection modules, it can be developed or enhanced based on the user's preferences or based on the system's architecture or system need. Meanwhile, in the server-driven approach, there are two streaming platforms they are generally being used. One of them is the HLS, HTTP live streaming. Meanwhile, there is a dash, dynamic adaptive streaming over HTTP. So if you are using Apple product, most probably you are using HLS. HLS have a .ts extension in simply. And meanwhile, in Dash, if you are using YouTube or Google product, most probably you are using Dash, and they generally have a .mp4 extensions. So these are in the server-driven component, side component. We have a HLS video server, thumbnail content generation, the playlist, and the segment processing. Because in the video domain, videos are being stored as the segments, like 10 seconds of segments in the server side. So there are four frameworks I have proposed based on in our discussion using the thumbnails. There are more than that, but like in this presentation or in this keynote, I have discussed the four one. One of them is a CL GIF, which is we can generate the GIF generation. Second one is the for the video summarization. Third one is the artistic media generation, like a thumbnail and the animated GIF. And meanwhile, recently there was another demo was I presented for the fast forward video summarization, which I will briefly explain over here. So in the CLA GIF, like in the mostly stories, there are like four stages. One of them, the most important stage in the videos, are the climax. So what we did, we tried to use that climax part in order to generate the animated GIF, which is more kind of exciting. So the traditional GIFs are generic or one size fits for all, as we discussed, and they don't capture most exciting that matters for the individual preferences. For example, in the sports video, the crowd roll or goal movements, we can identify using the highest pitch. In movies, we can do this by the dramatic sounds, like again analyzing the different pitches, and we can generate the animated GIF based on the those pitches. and specifically from the climax part. So we use the audio analysis to identify the significant movements. So this is the algorithm for the proposed approach. There was a CNN architecture in order to identify, instead of processing all the videos, we just selected those videos which are users' interest, and then based on that we were generated the animated GIF. So these are the proposed approach and the baseline approach, which was from the YouTube as well. And first one is I think from YouTube, second is baseline, and third one is the proposed one. And the second approach is the 𝗘𝗲𝗃𝗁 sum. In the proposed approach, what we did, we like based on the user preferences. One user may like again a horse riding scene, other user may like the shooting scene. So based on the user's interest, we were able to generate the video summarizations. So user need a quick video summarization, but as you might know, like 3D CNN require more computational extensive. They require more computational resources. Meanwhile, we use the 2D CNN instead of 3D CNN to reduce the computational while maintaining the quality of the summarization. But there are multiple use cases. For example, long lectures, we can shorten them, make the 10-minute summaries. We can analyze the feature films. We analyze the sports games, and along with the TV series, they can be further summarize. This is the 2D CNN architecture. Meanwhile, we compare our results with the different approaches. high-fidelity is one of the well-known in the industry, which was developed by the Yahoo team. We proposed them based on our analysis. It required like 85 minutes to process the video. Meanwhile, our proposed approach only required around 2 minutes. So this is the generated video from the proposed approach. But the first one is the baseline approach, and the second one is the proposed approach based on our thumbnail-based technique. Third one is the FRC GIF. Like mobile devices have a low lack of computational power for complex video processing. So based on the user's preferences, we were able to generate the using the low lightweight frame ranking algorithm that works for the smartphone devices and the other resource constrained devices. So we develop another CNN architecture, which should be the lightweight enough to generate the different multimedia content. And this is we analyze with a different approach. One is the host ATS along with the high-fidelity. You can see that the difference between the proposed approach, which is analyzing more prominent or exciting scenes compared to the other approaches. So meanwhile, this is the animated GIF. In FRC, we analyze or generated two different contents: thumbnails along with the animated GIF using the FRC frame ranking algorithm. In the hvidsum, we propose the new different approach. For example, in the video content have a vast OTT libraries, but it's really hard to navigate which content we need to watch. They are flow frame by frame traditional methods, which is again high computational resources are required, and there are privacy risk if we are focusing on the cloud-based solutions. So what we did, this is the content. This paper is based on the patent which is already approved in the in US and world as well. So this is the I have developed the technique based on the patent. So the patent was not a theoretical but a more kind of practical one. So in the key problems, what we did in the proposed traditional processing, which can generate the like personalized summarization, fast forward semantic based on the user preferences, and by focusing those ones. So again, I use the thumbnail based techniques in order to generate the fast forward video summarization. So this is the demonstration which I have used in the CVPR. So what I did, I have developed the CNN architecture. You can like most of the details are available on my page, which is in the QR code in the last slide. I will show you in the first slide as well. So I developed my Chrome plugin along with the CNN architecture. CNN architecture was able to analyze which frame is important. Meanwhile, the 𝗗𝗏𝗃𝗃𝗃 was able to fast forward those parts which are irrelevant to users' interest. Meanwhile, in slow speed or normal speed for those parts which is interesting for them. So these are the performance results impact, like based on the case study on the sports video analysis. Like if their video length is 1 hour 52 minutes, the processing time for the other approach is quite high compared to our proposed approach. Like for example, Hector, which was developed by Yahoo team, it required 85 minutes. Our approach analyzed in around 2 minutes. Meanwhile, the other performance metrics, like there was 70% reduction rate, because we were not analyzing the entire video. We are just using the thumbnail containers along with the specific segments. We were not requesting all the segments. Meanwhile, we have analyzed there are around 65% improvements in user satisfaction scores by doing the subjective analysis, and there are around 42% increase in the content engagement metrics based on our subjective analysis. So in the real world application and market impact, like we can use in the two different platforms. For example, we can use for the streaming platforms to personalize the preview and the trailers, user specific highlight reels, along with the actor focused content. Like as I mentioned earlier, we can generate their videos. Meanwhile, we can also do that for the social media, like generate the custom GIF based on the user's interest. By the way, this male and female is also generated by my proposed approach, which I present in one conference in IEEE conference. We can generate the content sharing optimization engagement based on the focus. Along with in the education sector, we can generate the personalized lecture summaries. Along with the student specific educational content, we can also do that. Along with the adaptive learning materials. So based on the user's need, we can modify the content, like but maybe summarize them, maybe fast forward or semantic analysis. So why this matters in 2025? Like privacy is the one of the main concern in several countries, like that there are different privacy regulations. So our data never, in a proposed approach, data never leave to the devices. Meanwhile, there are rising costs, like a cloud and the cloud or server driven approaches require a lot of require computing and energy cost globally. So in our proposed approach, we require minimal server resources because we are processing on the end user devices. Meanwhile, we are meeting with the users' expectations as well, like by generating the content based on their need, along with securing their privacies. And in the market trends, their AI marketing keep growing, accelerating, and their personalization demand is also increasing with the privacy need as well. So the proposed approach is address all those trends simultaneously. So in the key takeaways, like a personalized media is essential for the next generation streaming platforms, and the client-driven approaches offer substantial benefits for privacy and efficiencies. The proposed approach demonstrates all those significant performance improvements in different areas. So remember, like in the cloud, your data is someone else's computer. Meanwhile, in AGI, your data is your problem. So at least it's our problem. So we need to focus it. So thank you.